Okay, I left off with this coming up with uh, a wrong answer, and as it turns out, let's see. Oh, that's interesting. Okay, as it turns out, I had put in here this matrix. Wait a minute. I had a minus sign in the matrix before, so you can see there's a minus sign right here that should not have been there. And this is, and the only reason I'm bringing this up, there's something flawed in general here. So there's the matrix that I came up with, but there's something deeply flawed here to begin with. And let me see if I can give you some clue as to how you might find this. So I'm going to go off kind of into the abyss for a minute, but there's a reason for doing that. Is that viewable? I mean, I guess it is. I can't make a judgment with my eyes because I need glasses. So I got this matrix. We came up with it last time. You go in here and you do something like this. Okay, I got to do the right-hand side too. Let me go back up. I'm looking for the right-hand side. Okay, I think that's the right-hand side. 20, 20, 30, 30. Okay, so then if you go in here, go back and find the one that says inverse. Here's what's interesting. You get infinity. And you're looking at it and you're thinking, okay, something I've done is terribly wrong. And there is something I've done that's wrong. So instead of, I don't like to avoid it. So I like to kind of give you an idea of what you can do to this. Okay, so I've got the K and I've got the right-hand side. So you can create a new matrix, call it M, I don't know, which would be the K, and then I think if I do this and then the right hand side, I put them side to side. No, I don't. Don't tell me I have to do, oh, that's right. And so, yeah, sorry. So I'm tacking this on as the last row of a 4 by, there's 4 rows, and now there's 5 columns in which, that last is the right-hand side. And I think, if you remember back, that was called the augmented matrix or something like that. Now, I didn't check on Octave, but I know in MATLAB they have RREF, reduced row echelon form of M, will tell you something interesting. It tells you what it does is it starts by trying to reduce everything down to the point where you have an identity and then you have a vector on the right hand side. So this one that says 0, 0, 0, 1, that's the right hand side. But what you notice is that last row, it's 0, 0, 0, 0, 1. So if you look at it, you realize there are not 4 equations there. There are actually 3. Now, you can sort of, a mathematician would want to stop and take a look at this. There are several things you could do to this to figure out that one of these is a duplicate of another set of those. But that's, that, I don't know if that's linear algebra you do that in or what course you do that in. But the key is why? Why is this? And what fundamentally happened here to create that? Okay, so kind of to review, I had this, I did a slice, so I did a section. So I had this funny truss. Then I go in and I look at this and I say, somebody's asking you for the HJ, the force in the HJ, remember the HG, the FG, and the EF. So if you look at it, okay, I don't think I did those in order, but the oh, okay, well, the other thing is I sectioned it the wrong way, but HJ, HG, FG, this should be EG. That's supposed to be EG. That's, remember, EG right there. So that's the first thing I did that I guess you could classify as a mistake. But did I carry that through? Is there an EG? Yeah, there is an EG right there. But can you tell me what is fundamentally wrong here? It's not fundamentally in the sense that I've missed a number, say, or I've missed a number here, or this number's wrong, or something like that. It's a fundamental thing. It's deeper. It's a deeper fundamental problem. And the deeper fundamental problem is that in a structure like this, I essentially have some of the forces in the X, I have some of the forces in the Y, and then I have some of the moments, and that's all I've got. I don't have another term. So no matter how many other terms I do, and I could prove it to you by doing one, and the fact that I have it in that reduced row echelon form, I can show you that. I only have available to me 3 equations in 2D. Now in 3D, I've got 6 equations, but I'm only in 2D. So in fact, I've got a problem. I've got 1 unknown, I've got 2 unknowns, I got 3, and I got 4. So how do I solve it? And first, maybe I should just, as a rule of thumb, let's say I didn't recognize that. And let's say, oh, I've repeated an equation. Maybe I should do something different. Okay, you know what I'll do? I'll do some of the forces in the X, and I'll add it to it. So I'll say I'll add a row down here that's some of the forces in the X, and we'll just see what happens to it. So what, if you do some of the forces in the X, looking at this blue object right there, just as a case in point, I get F, okay, so I'm going to make that to be positive. I get the FEG first, minus FEG. Hopefully I don't goof up my subscripts. The next thing is I get this FFG, and that's 45 degrees. So I get minus F, I don't know why that does that, FG over square root of 2. And then I get the F, and I'm going to have to zoom that in. HJ. There's my H, and there's my J. Uh-oh. What did I just do? Okay. Minus FHJ. Hang on. Minus FHJ. Is that right? Correct? And the reason I picked the X equation is because I had I didn't have to worry about this 10,000 here. So I thought it might be entertaining to take this, the component of the X there, and this, put them together, add an equation. There isn't a right-hand side, so it's just equal to 0. So then if I take this equation and add a new equation and think to myself, okay, I can do reduced row echelon form with the new equation, it should solve it, right? Well, the problem is, let's see, give me a second. I'll first start with HJ. I'll add this equation. There's a -1 down there. So I'm operating down here. Then I got EG, which is this one. And then I got FG. I don't have an HG, do I? I don't have an HG. Just double check. HG goes up. So I don't have that. But then what I got there is 1 over square root of 2. And then I have that. So there's a new equation. So I might say, oh, I forgot an equation. Let's see if I do that. Now I haven't done this beforehand. So this is basically me adding to this. So now I got M. I'm going to add a new row to this M. Okay, here's my M. Okay, so I got to add a new row. So I think I'm going to call it, how about N now? n is going to be equal to this. And I'll say m, a new row, and in that new row is going to be minus 1, minus 1. Was that a minus 1 over square root of 2? Yeah, it was. It was minus. That should have been a minus. Minus 1 divided by square root of 2. And then there's nothing. And then on the right-hand side, the augmented. Y'all have heard of that before, haven't you? Have you heard of the augmented form? If not, I'll talk about it in a second. So there's the new matrix. So it's got, it's got another row, right? So then if I do, what did I call that? Reduce row echelon form. Did I call it in? Yes, I called it in. Guess what? I don't get another one. If you look at the last, it's 0, 0, 0, 0, 0. So the key is, no matter how many moment equations I do, no matter how many force equations I do, I only have 3 independent equations. So how do I solve this? There was a hint that I talked about at the beginning of last period. But do you want me to take a few seconds and talk about the augmented form? Would that be, this reduced row echelon thing, let me click this and see. I think if I just type in, hang on. Here, let me get rid of all these windows. Too many windows. I could keep that one. Okay. If I just do RREF, it's got to go to MATLAB. It has to. Okay, there's something about eHelp. I don't know what that is. Okay, where's the MATLAB? Okay, here we go. So it's the same thing that you get here. And I probably should have done the extra part. So he also can return a P. So here, I don't think that's of any use to us, but here, we'll say R P, just like what he's got, equals to. Now I think, oh, okay, so the P is kind of useless, kind of to us. So it's a way of determining how many actually equations you got. You can list all the equations you want, but there's only so many of them that are going to be useful to you. And so let me give you an idea of what, just to complete this. So if you had a matrix that looked like this, if you want to put it in augmented form, you just list, and I'm going to use the copy thing here in a second so I don't have to write all this. And usually in a math class, they'll put these little dashed lines here, and what they'll do, oops, wrong thing, wrong button. They'll take this, copy, and I'll just paste it, and then it gets moved to the right, and then the matrix itself gets done like this, copy here and paste, and then it gets written like that. Now the benefit of the reduced of this and for doing it by hand is you do an operation or something. Say you take, I'm going to take row 1. So row 4 now is going to be I'll say row 4 minus 10 times row 1. So if I multiply minus 10 times row 1 and then add it to 4, I probably shouldn't be doing this, but what you'll get all these will be the same. In other words, all this is all exactly the same. Obviously the little thing here needs to be widened. So all that doesn't change at all. But what happens is you take 10 times this number and then that, you get a 0. 10 times that, the other, is just 0. So what you're doing is you're eliminating these, and what you're going to do is go through and try to eliminate all these on the lower part. That's the goal in these row operations. And usually the best way to think of it is if you're doing it by hand to do that. That's what it's doing in the computer. So then it'll take this. So obviously nothing happens here. 10 over square root of 2, and there's 10. Then you got to take 10 times that, so minus 20, not 20,000, but 200,000, right? And then you add it to 30,000. What is that? Is that 170? Isn't that 170? And so then what happens is you have a new matrix. So you accomplish one goal, and your one goal is to get rid of that. Now your next goal would be, a math person would say, oh yeah, I want to get rid of that. I want to get rid of that term. And then guess what I want to do? The next thing I want to do is I want to take this and make it a 1, that make it a 1. Ooh, I can't do that. But what you'll find is there'll be a number gets populated right there. So in effect, what you're going to end up with is this thing, just like this. And you'll see there's ones on the diagonal. And except for this one, which is like very upset at you, or upset at me, because it says I don't have but 3 equations. So I can't help you here. So it's not going to get an answer. So what did I do? What should I have done to resolve this? So that's what reduced row echelon form is. And that's what the augmented matrix is. Well, we recognize to begin with, okay, so if I look at H, and I think we talked about this because I got the yellow marks and the green marks. Oops. So if I look at this and say, I'm going to do a node there, nodal analysis, I'm going to look at H, here's the pin, I'm going to have some kind of force here, I'm going to have some kind of force here. So this would be FHJ, this would be FH, and this one would be FHG or GH, FGH. Say. Now, look at that pin, sum of the forces in the Y tells you all these ones that are yellow have to have no load on them. They're zero load members. No load members, yeah. So in effect, if I go in here and say, how do I accomplish this? Well, I can take that and put in a new equation here. FHG equals 0. See what happens. Now I'm not going to pay any attention to this last equation. So what I'll do is I'll try to do that with a new augmented form, or a new, yeah, here we go. So I'll go back to the point where, okay, that was the equation. I had M, which was the original one. And now I'm going to try to put in a new row, which is going to be FHG. Where's HG? This one. Now, it's going to be that. So if I look at that row, that's just FHG times that equals to 0. Let's see if that works. Now, I haven't tried this before class, so if it doesn't work, I get mud in the face. Oops. Okay, there it is. Okay, the right-hand side still has to be 0. Okay, let me make sure I get all these sequences. Get a 0, another 0, a third 0, and then a 1. Did I do that right? I got too many. Okay, it's supposed to just be that. 0, 0, 0, 1, and then 0. Now, I think I already did the term reduce row echelon n. Now, what it does, okay, so it didn't give me the answer, but what it told me is that I can actually solve that. So let me see if I can. Okay. Or I could just take that complete row out. That's the other thing I could do. If I recognize that, I can take this like so. And it just so happens I'm lucky. I did not plan this. But I can take this. And that might be an easier thing to do. Take that. Then I'm going to take this. And, uh-oh. Can I move it? Okay. And then I take this. Oh, I almost moved it. Okay. Yeah. I can do that. And try to solve that one. Now that's a little harder to put in, but it shouldn't be that hard because actually, well, I'll go ahead and do it. Here's what I'll do. I'll just call it, I'm just making up variables now. Okay, 1, 0, 0, 0 minus 10. That is not a 0. That's the mistake I made last time. I'm getting lost. I mean, I'm getting lost. The lecture is getting lost in the forest here, so to speak, if you know what I mean. So let's just try this. REF of B and see if I... I'm too used to using different languages. So reduced row echelon form says, these are 3 independent equations. So I've got 3 equations which will work, but now I've got to do, a new right-hand side. Right-hand side gives me 20,000, 20,000, and 30,000, I think. And if I type them all in, equals to the bracket. Now I can do inverse. I think I called it a B times the right-hand side. And now I get 3 actual numbers. So I get the actual answer. Okay, hang on. Copy. And we're going to go back and double check this. So I get FHJ equaling to what appears to be 20,000. I get FEG, what appears to be minus 3,000, which only means I assumed it wrong. Assumed wrong direction. DIR. And then I get FFG 14, 213. So if I take my drawing here, and luckily I can just, okay, first, I'll just go ahead and copy the whole thing. Let's do a copy. And then I'll move way over here to the right, sort of drop it up there. What you'll notice, okay. So FHJ. Okay, there we go. FHJ is 20,000. This one's 0. FEG, EG. Okay, so essentially what this one is, the EG is going the other direction, and it's 14, 14. And then the other one is, no, that was 3,000. Sorry about that one. This one was the 14, 14. Which kind of makes sense. That looks like square root of 2 in there. This one was 3,000. And so you're pretty much done. But this was too much actually for the first case to do. Um, so maybe what we'll do is we'll go and look at a simple one that he has, if y'all don't mind. I can still log in here. Because he's not going to do one that big. He's going to do a smaller one. So fall and static. And what I'll do is go into content. I should have just picked one that he had. Okay. Yeah, okay. I didn't think I was there. I thought I was somewhere else in here. Yeah. Okay, that is there. Yes. Good grief. Okay. Okay. Then it jumps around. Okay, so we're not going to look at space trusses right now. Method of joints, we talked about that. Then zero force member, method of sections. Okay, so I'll talk about zero force members for a few seconds, but we just did. Although he may not give us, well, it's probably pretty good. If you look at it, any member of this one, for example, A, that's a classic case. If you break A apart, and you look at FAB, which is this term right here, and the FAF, you're basically going to get that these two members don't do anything. Also, this ED and DC are going to be the same thing. So essentially, you know, he does this same thing here. A little bit more complicated because it has sign of stuff, but essentially that is the official trust. That is what you're. You can take the zero force members off and then do the other members, and that's what he's doing here. So essentially, if you have something that's sort of hanging out there by itself, like an A, or like I had, the ones that were just hanging. Let's see if I can find one in here. Now, here's a D and a C, and what you're going to find out is the one that goes from A to D, and then A to C. Both of those are not going to carry a load, but the only way you can do that or identify these is sort of think about this from looking at it from a free body diagram of D right there. So you do that, you look at it. This one's going exactly the opposite direction. So CD is in a direct line with ED. And so this other one, whether it's perpendicular or not, doesn't matter. There's no force perpendicular to the line that goes from C all the way up to E. And so that gives you nothing there. He should have another picture here where he's got something that's offset. Okay, so this is an angle right here, theta. It doesn't matter what theta is. It just matters that CD and CB are in exact opposite directions. So you set up a coordinate system Y along here and an X along here. So yeah, you can take sine of anything and do anything you want, but you get this one term, FCA times sine of theta is equal to 0, gives you this load FCA doesn't exist. And so to identify the zero force members, you got to think like a pin, so to speak. But then you think like a section. Well, he calls them method of joints. Some books call them method of pin. That is not where I wanted to go. That's the example. I wanted to go straight to the method of section. And in the method of sections, all you're doing, okay, is you're slicing them, a member. And so you see He's obviously, in this one, he's going to want to know the force between B and C, G and C, and G and F. So he essentially slices it. What's interesting is one person in the room can look at the left hand slice, and another person in the room can look at the right hand slice, and you should work it through and get the same exact answer. But what you'll notice is if you do the left end, you do not have to find the support loads, the dx, the dy, and the e. But if you do the right end, you do. So sometimes it's better to do a section in which there's nothing supporting it on your whole section. Like this is a free section completely. And so all you're doing there, you could sum the moments about C, and you could pretty much tell right off that this load is twice that load. So if you go down, I don't know if he solved it. So he doesn't solve it. But if you sum the moments about C, what you got is 4 meters over 2 meters and 2 more meters times 1,000. And then you got 2 meters times this. So you got 4 times 1,000 equals to 2 times the FGF. And you just move them apart and you divide, you'll get FGF is 2,000. You can also sum the moments about this G point. If you sum the moments about G, then the FGC and the FGF go straight through there, which tells you that FBC, 2 meters times FBC is equal to 2 meters times 1,000. So it turns out this load is 1,000 and this load's 2,000. And you could just sum the forces, I guess, I don't know, sum the forces in the Y, and that would give you that component. Sorry. So sections make it easy to do larger problems. Here, let's just pick one that he might want us to do instead of making one up. Fundamentals, I don't know. The fundamentals, I think, have the actual solutions on. Okay. Okay. It's not able to shrink, so I don't know if I can get. Maybe if I click it, I think it becomes. Well, I take back the comment I made about his trusses being simpler than mine. They're not necessarily, are they? I don't know. Which one do you like? They all look different, but they all look the same. Okay, here's one. Let's start with the simple one. I don't know what he's asking, but I'm here to get the picture first. I don't think I need the plus symbol or anything. Let's see. Okay, let me go back and find out what the thing he's asking is. 37 and 38. Determine the member in EF. Okay, tell you what. I don't think it really matters which one I do because I think they're going to both be the same. So I'll just do this. So I don't have to move things over. I can just put them out there. Okay, so he says P1 is equal to 9. I'm just going to make that 9. I guess that's P2. I'm going to say that's P2. And I guess the other one's P3. It's going to be 6. So then he says, determine the load in EF. Where's EF? There's EF. BE. BE, that's that one. BC. BE. BF. Well, it looks like I'm gonna have to do. Did I? Where's B? Wait, I marked EC. Oh, I marked. Okay, wait a minute. I marked that. Which one did I? Okay, wait a minute. EF. Oh, BC. Why does he have this extra member in here? F, EF, BE, BC, BF. He just wants this one to make me work extra. I'm going to ignore him making me work, and I'm just going to do this. So I'm going to slice it like this. Now, unfortunately, I gotta, either way, this is not a free thing, so I've got to find one of these loads. So over here, I got to find two of them. However, the second one shouldn't be that hard. If I look at this, this is 6. I think that was 6. Yeah, P3 is equal to 6. So that's got to be 6 either, because I don't see any other X load in here anywhere. So I say it was harder, but it's not. Then what I could do, I can do something really strange, okay? I'm trying to figure out the easiest way to figure out this one or this one. Trying to eliminate as many loads as I can, but I don't think I'm going to get any refuge there. So I don't know. I'll sum the moments about A equals 0. And I'm going after this. And what I'm going after is dy. Okay, so, and then what I'm going to do is slice it. After I get the dy, I'm going to slice it. The reason I'm going to slice it and take this right end is because I'll only have this load and this load. If I take the left end, I'll have this load, this load, this load, and this load. I don't really want to work that hard. So I would like to work as least I can. So I'm going to sum the moments about A to find this. So I don't know, which one do I want to do? So here we go. This is plus. That's going that way about A. So that's a minus 6 times the height of this thing is 3. Let's see. This one's going that way. So that's another minus. And that's a 9. And that's a 3. And then I got this one going that way. And that's a 12. Oh, and that's a minus. That's a minus thing. 12. And then I got 6. Get rid of that. And then the only thing I got left, do I got in it? I don't. I have 3 applied loads and then the dy plus dy. Because dy goes that way and it's 369. And so dy is equal to, I don't know. So if I divide everything by 3, this is going to look stupid, but 3, 3, 3, and 3. Then what I'll get, moving the other stuff over, I'll get 6 plus 9 plus 12 times 2 over 3. And I've been using this silly thing. I should be able to do that in my head. Should I? I should. But then again, do I want to? Okay, so I get 2 plus 3 plus 4 times 2 is 8. That's 13. I hope that's right. If it's not, let me know. I'm just going to keep going. So now I'm going to do a slice. So what I'm going to do is do a new thing, but this time I'll mode it with freeformed. And I'll just go in here and do this. Go ahead and include that 3. Yeah, I don't even want to look at that. So that's what I've got. So now I'll just drop down here, paste it. So now I got my method of sections, and I can choose any direction I want. I can choose silly directions like that one. I'm pretty sure that's maybe not right. I'm even going to choose that one wrong. And then I'll choose this one. So this was FE something. FEF. FEF. This was FE something else. B. And this one was FCB. It's got to be B because it's the same point back there. Now, if I want to do the simplest thing for myself, I'll just have these two line up and sum the moment. That's got to be B. So I'll sum the moments about B using 0, and that's the direction I'm going to take as positive. So the only thing I've got here that's unknown is this thing going this way. That appears to be positive to me. FEF. And I think this was 3 meters, so it's 3. Then I got this one going that way. Hey, that's the same thing, 12 times 3. And then I got this one going that way, which is minus 13 times 3 and 3, give me 6. So, hey, looks like I can divide by 3 again. Oops. So what I get is FEF equals to, move that over, and I get, so if I move this to the other side, it becomes positive, and it's 13 times 2 minus 12. So I don't know, 26 minus 12, isn't that like 14? If it's not, let me know. Does it seem to be 14? So that's EF. So what should I do? Should I just go up there and write it on there? Now, I'm a little confused there for a moment until I realize this 12 interfered with me. If I didn't have that 12, would I be going the right way? Did I make a mistake here? Positive. I did. Where's my mistake? That's correct. Let me do that. Well, luckily, that makes it a minus 14. I think. Oops. Well, I'll just erase it and make minus 14. So I was purposely assuming it the wrong direction, and then it came out to be the right direction. I'm like, uh-oh. So in fact, it is 14 that way. Okay, so the next thing is, who do I want to find next? If I sum the moments about E, and this doesn't produce a moment, neither does that. So if I did make an error right here by using this equation, it's an error is not propagated. Okay, so I sum the moment there. I don't know which one I should do first. How about FCB? That moment spins that way. Its moment arm is 3 because that's still 3. Then I'm going to line them up vertically. And then this one goes that way, which is minus 12. Wait a minute. It doesn't have a moment arm. It goes right through E. That's funny. And then this one goes that way. Well, that's quite interesting because that is plus as well. And it's 13 because that's its value right down here. And then its moment arm. There is a lot of 3's here. That's kind of beneficial. I don't have to remember too many things. because then that makes FCB equal to minus 13. So that's beneficial because now I've assumed it the wrong way. And it goes the other way. And what was the answer? What was the thing? 13? Okay, did I make a mistake? You're supposed to tell me. I'm just going, and I'm relying on you to find mistakes as I go. I'm not 100% today, so your expectations should be kind of a little lower. You don't want that clue, let me tell you. Okay, the only thing I got left is this FEB. And the fact that that was 3 and that's 3 gives me that this is 45. So I don't know, my inclination off of that one is just to sum the forces in the y direction. And just, because then I got this, I got that, and then the y component of that. So I could start over here and say 13, ooh, minus 12. That's easy enough. So that part would be 1. And then this part's going to be the direction I assumed it is. It's going to be minus FEB over square root of 2 because it's 45 degrees. So that means FEB has got to be equal to just square root of 2, because if this is 1 and then it moves to the other side, they basically move opposite each other. And so you get that. Now, if I want to check this thing, there's a simple way to check it. And you could almost check it visually. If you notice, this is 14 and this is 13. Then you add this, which is, if this is FEB, square root of 2, then its value is 1 that way, its value is 1 that way. So in fact, if you add 13 and 1, you get 14, I think. So in fact, it checks out there as well. But up until that point, really, if you think about it, I've exhausted my 3 equations. I got that one, I got that one, and I got that one. Anything else, any other equation that I use is going to be already embedded in there. But you could still use it to check. You could check your answer like that. Did that make sense? The 13 and the 14 and the square root of 2. If it didn't, I can basically, in other words, what I was saying, sum of the forces in the x equals 0. There is no x. There is no x. But what I have here is 14 to the right, 13 to the left. There's my 14, there's my 13. And then I've got a little component going to the right there. That component, that value is 1 over square root of 2. Well, turns out that makes this 1, that makes that 1. So then I get 1 to the left, and in fact, it's just equal to 0. So that's all I'm saying is this equation is already embedded somewhere in these. If I wrote these 4 equations in matrix form and did reduced row echelon, I'd only get 3 equations. So, so I guess I'm done. Is there any questions or something? I guess I got to come up with a couple problems. I'll come up with one problem that has nodes and one that has sections. If y'all are okay with that. I didn't even find the other member because I just didn't want to. That's just mean to ask for this one. But, you know, if you were given that, what would be the simplest way to do that? Because I'd already have this being square root of 2. And then this, what's that value got to be? Because some of the forces here in this direction, so if I did this as a pin, then this has got to be 1. Because remember, this load here was 1 over square root of 2. I'm sorry, it was the square root of 2. So it was this. So that means its y component is 1 as well as its x component. If I'm looking at the x component, am I making sense? So in other words, what I'm saying is we found out this. Which way was it going? Was it going away or towards? Yeah. So in fact, it's going to be like that. So you're going to be like this. And that value is going to be 1. So I guess it's okay, because then you could break away and do the node approach right there. Just look at that one node, and then that would give you that. Although I just out of principle, I don't want to do it, because we're in the method of sections. So, does it make sense? And I'll just assign, I'll go ahead later today, and I'll assign a couple problems for Sunday. You could start on them if you wanted to. Let's go ahead. The only reason I'm going to do 2 is because sometimes the nodal things, if he's asking for every single node, you'll find it's not hard, but it's long. And the sections will be shorter unless he does something like this, in which you can basically solve those 3 and then have to go across and do the one over to the left. So I'll look and make sure there's not one that has a question that's off to the side, you know, that basically you can just section the beam or the truss the way you want and solve it. So that's the reason I'm going to have 2, because they're going to take a while to do. Put them on page and you're sitting there working them, and it takes a little longer than you think. So I guess I'm done. I don't know. You think I'm done? I might be done.